Hello and welcome to another episode of Black Hole Battles game development on Let's Code Physics. Recently we had some success getting our enemy ship to navigate itself around the nearest black hole, so it looks through the list of black holes that are in the play field, and it either moves toward or away from the nearest black hole based on however far away it is. But what would be nice would be if we could give it a little bit more decision-making capability. And what I'm thinking of for today is, let's say you've got the nearest black hole here. So obviously the enemy ship is really close to that black hole. It's going to want to avoid it. The question is, should it go around in this direction or should it go around in this direction? If there were nothing else in the game, those would be basically equal decisions. It would kind of come down to what direction is already pointing, and then it should continue on in that direction. And that's the way we have it set up right now. But what I'm thinking about now is having the enemy ship identify not just the nearest black hole in BH, but the next nearest black hole in BH. So you imagine you've got this field of black holes. The ship can identify both the closest black hole and the second closest black hole. And then depending on the strategy that the ship is employing at the moment, it can either go away from the nearest black hole or, away from the next nearest black hole or toward the next nearest black hole. So for example, suppose the ship is running strictly evasive maneuvers. It's strictly trying to survive, not trying to do anything fancy. It would go away from the next to nearest black hole. But let's suppose that it was feeling a little bit more daring. Like, say the player ship was chasing it, and it wanted to give the player ship a reason to get away from it. It would go toward the next nearest black hole. It's obviously not going to go, straight toward it. It still is going to try to avoid it. But we can set it up to where its initial trajectory is going toward the next nearest black hole. Or you imagine if the player ship were somewhere in here and the enemy ship were the one chasing the player ship, then the enemy ship could try to steer the player ship toward this black hole over here. And so we can set up some sort of decision tree for the enemy ship based on whatever its aggression level is. So that gets into some of the gameplay strategy. We would define some sort of aggression level for the ship, which could change, moment to moment depending on, how in control it is, how dense the black holes are, things like that. And so what we need to do is we need this enemy ship to be able to translate these two locations into an away command and a toward command, and then the aggression level determines whether you go away or toward. And so I've been working out some of the geometry for it. We already have this relative position vector here, RVEC, that goes from the nearest black hole to the enemy ship. So we're treating the nearest black hole as the origin. And so this vector is going from nearest black hole to the enemy ship. All right, so that should be RVEC equals, it's always the field point minus the source point. So that should be the enemy ship position minus the nearest black hole position. So the technical term for this is a relative position vector. And then we would also need the next nearest black hole's relative position vector. So that would be a vector going from nearest black hole to next nearest black hole. We'll call that one BVEC, B for black hole. So the BVEC is just going to be, again, the point you're going to minus the point you came from. So that's going to be next nearest black hole dot position minus nearest black hole dot position. I'm glad I went ahead and decided on my color coding because this is starting to get crowded. And so for this thing to go away or toward, it needs to know what direction the next nearest black hole is relative to this position vector, relative to the relative position vector, if you will. So the ship needs to be able to identify this angle, let's call it theta for right now. And I'm putting an arrowhead on it because this angle theta needs to be considered differently than the same angle theta going around the other direction. So if this, let's say this was 120 degrees, if the next nearest black hole were 120 degrees around this way, say in this corner, then the away direction and the toward direction would be flipped. And so I need to be able to determine not just the magnitude of this angle, I need to be able to determine its direction, its sign, SIGN. And in order to do that, I need its sign, SINE. Because when you take an angle's cosine, the positive and negative kind of goes away, because cosine is what we call an even function. So if you take cosine of 30 degrees, it's the same thing as cosine of negative 30 degrees. The cosine absorbs the negative because it's what we call an even function, and so it loses this information about whether this is a counterclockwise rotation or a clockwise rotation. So we do not want to use the cosine in this case. What we want to use in this case is the sine, because the sine of an angle, any angle, is equal to negative sine of the negative angle. Right, so sine is what we call an odd function, meaning if you put a negative sign on the function argument or the function input, you get the negative out front. So it sort of transmits the negative out into the front. I guess now that I'm looking at this, the more traditional way of writing this is to put the negative over. Is put the negative over on this side. I mean, it's the same thing, right? But you've probably seen it this way in a textbook. And so in order to get the sine, we need to take the cross product of these two vectors, because the cross product of these two vectors, r vec and b vec, r vec cross b vec, that's going to give you the magnitude of r vec times the magnitude of b vec times the sine of the angle in between them. And this thing will be positive if it's a counterclockwise rotation and a negative if it's a clockwise rotation. And so in order to get the angle, what we have to do is we have to do a little bit of algebra there. So we have to take the arc sine of this cross product, r vec cross b vec, and then divide it by their magnitudes. That's this part right here, the magnitudes. Only I'm not really concerned about the actual number for theta. I'm really only interested in the positive or the negative. So I could in principle leave out these magnitudes, but now I'm remembering arc sine doesn't like it when you provide it with a number that's greater than 1 or less than 1. So we do need to include these magnitudes, or at the very least we need to turn these into unit vectors, which C# can do for us. And so basically the way it needs to work is that in order for the ship to move away from the next nearest black hole, right, that's this away maneuver here. So in this case, for example, going from r vec to b vec, this angle has a counterclockwise direction. So it's a positive angle. So this thing needs to also be in the counterclockwise direction. You see it's going counterclockwise. It's also got a positive angle. You can do the... Well, now I wish I had my webcam on because you can see me doing the right-hand rule. But basically what that means is that sine of theta, or excuse me, it means that the sine of the ship turn needs to match the sine of theta, SIGN, positive or negative. Likewise, or conversely, in order for the ship to move toward the next nearest black hole, so the more aggressive move, again, this one's a counterclockwise motion, but this one now is a clockwise motion. So those signs, SIGN, needs to be opposite. So the ship turn needs to be opposite sine of theta. Cool. So we've got a simple little way. That's just a couple lines of calculation in the code that will allow us to have the enemy ship moving away from the nearest black hole, or excuse me, away from the next nearest black hole or toward the next nearest black hole. It's just a nice little strategy maneuver. But the first thing it needs to do is be able to identify what the next nearest black hole is, because currently under enemy controls, we identify the nearest black hole, or we call it closest black hole here. But we needed to identify the next closest black hole. So that would be the first thing we need to do, is have structure this to where the enemy ship can identify the next closest black hole. So where do I define closest black hole? Okay, so let's just follow suit here. Int next closest, not closet, black hole equals 0. Actually, I guess those, no, let's start them out with both as 0. Index of the black hole second closest to the ship. Cool. And so what I need to do is I need to be able to store that information. I need to be able to store the information about the next closest black hole. So what's going on along here is we're evaluating whether the current distance between the black hole and the enemy ship, which actually, now that I look about it, I have this reversed compared to how I have it defined over here. Because over here I've got enemy ship minus nearest black hole. Here I've got black hole minus enemy ship. But the reason I have that is because this gravitational force is attractive. And so technically, if I were to do it that way, there would be a negative out here. So I just have to remember to flip that. I'm going to have to recalculate that anyway down here. So I'll just remember to, let's call this negative of relative position vector. That'll just be my note to myself, and hopefully I'll read it later when I get to that. So let's see. We've got the next closest black hole. So here it's replacing the current closest black hole, whichever one it's currently evaluated as a current black hole, as a current closest black hole, with the closest black hole. So basically all I have to do is, before overriding this, I just need to say next closest black hole equals closest black hole. And that should suffice because I've already identified this closest black hole as being closer than any of the others that came before. And if any other black hole ever beats that one in terms of being closest, then then that previous one must have been the next closest. Cool. And so the next thing I would need to do would be to pass a new argument over here as next closest black hole. And so I'll need to add an argument down here to avoid black hole, comma, IB, I need another int IBP for IB primed. How about IBN for IB next? So let's see here. So let's give this thing some comments. So IB equals closest black hole, or index of closest black hole. Oops. And then IBN equals index of next closest black hole. There we go. I'll also need to, at some point I'll need to determine the for lack of a better term, the aggro level of the enemy ship. So let's put that here somewhere, of need to determine aggro level. There we go. And then we'll use that in the determination whether we're moving toward or away down here. For right now, we'll just either set that manually or define it in terms of, or we'll just randomly choose it or something like that. But for right now, the next thing I want to do is work in our calculation of the angle and adjust the enemy ship's direction accordingly. Although actually, now that I think about it, I don't really need to evaluate the entire arc sign, because whatever sign, positive or negative, that this cross product has, the arc sign, therefore the angle, is going to have the same sign. If this thing is positive, then this thing will be positive. If this thing is negative, then this thing is negative. So I can get the rotation either way. I can get a positive or negative for the rotation. That's the only thing I really need, is the SIGN of this cross product. Okay. Let's leave out the determining the... Well, I guess I need to define the aggro level. So let's do this. I'm probably going to need to pass that as an argument from above. So let's have int aggro. And I guess let's put that up into... fixed update, because I would want to... Well, I would want that to pass from one to another. So I guess let's actually put that into... Let's put that up here. So we'll have public int aggro level. Ships aggression level. If I'm misspelling aggro, please correct me. I've only ever heard it, never seen it written, which means I don't need to pass it as an argument here because it'll set it up here. And let's have the aggro level start out at 0, just to give it a value there. Let's see here. So let's say, let's just have aggro. Let's just set it to 0 for right now. I think what I'll probably do is aggro greater than 0. It's probably going to be aggressive, and aggro less than 0 is going to be defensive, or less than or equal to 0. There we go. Cool. Okay, so let's see here. Here I've got the helicity calculation. Here I've got the rotation direction. So let's do this. Let's figure out the cross product here. What do I want to call that? Let's call that float next black hole rotation. And so we need to take the cross product between these two vectors. It needs to be rvec cross bvec. I believe. Let's see here, because this is... Okay, actually it needs to be the negative of that, because my rvec is going from this rvec in the code is actually the reverse of this rvec here, because it's supposed to be enemy ship minus nearest black hole, but this is nearest black hole minus enemy ship. So what I'll do is I'll just put a negative sign on here. And so we need to take the cross product of this vector rvec. So I need rvec dot... All right, let's think about this. I'm calculating the z component, right? Because that's the only thing that matters is the z component of this cross product. So when I want to do a cross product, if I wanted, oops, I forgot to change my color back to red. There we go. So if I want rvec cross, what did I call that one up here? bvec. And I'm just looking for the z component. Then for me to get the z component, first I take the two that are in alphabetical order. So that's going to be rvec x times bvec y, and then you subtract the one that's in reverse alphabetical order. So that's going to be rvec y times bvec x, right? Because it goes x, y, z, x. Only I'm flipping that. So let's go ahead and save ourselves a calculation, get rid of that negative sign at the beginning. So let's take this part at the front, rvec.y times bvec, which I haven't defined yet, dot x. And then we'll subtract the reverse, rvec.x times bvec.y. Cool. Did I put a semicolon up here? I did. Okay, good. So I just need to get my BVEC, and that one let's define the correct way as next nearest black hole position. So that's going to be, how did I write that up here? Black holes of IB.transform.position. Paste. Okay, so I want to do the same thing because I'm going to take the next nearest black hole. And I think I called that label IBN. Is that right? IBN. There we go. Oh, and I need to declare this thing's type vector 3. BVEC equals this. I need a semicolon. Cool. So it's taking black holes of IBN. So this is the relative position between nearest black hole and next nearest black hole. Oh, I think I need to, but I zoomed that in for y'all. There we go. Helps me too. Let's see here. Let's see. So I defined that, and this is the direction of rotation between nearest black hole and next nearest black hole. Cool. Cool. Let's see. So the next thing I need to do is, based on the aggro level, I need to let this determine the rotation here. So let's think about it this way. Let's go ahead and have it calculated based on the... Let's go ahead and have it calculate... Well, yeah. Let's go ahead and have it calculated based on the helicity. And then here we need to rotate toward or away from next nearest black hole based on aggro level. So if my aggro level is greater than 0, I always feel nervous about using integers like that because it's technically supposed to store it as an integer, but let's make it a tall. No, I wanted that. Excuse me. No, I do not want to restart my computer right now. I just shut down my computer, goodness. Let's have that one be a private up here. I still need to clean up my publics and privates up here. Private float tall equals, let's go 10 to the, no, actually, 10 to the minus 3. There we go. That take me back to tall. There we go. So if aggro is greater than tall, then what we want to do is we want to have the ship, let's see here. So we want it to turn toward it, right? We want it to turn opposite of the sine of theta, right? Because this one's rotating this way, toward is rotating the other way. So we therefore want rotation direction to equal negative, do you know sine function? Public returns the sine SIGN of f. Perfect. Next black hole rotation. Oops. Semicolon. Perfect. And let's see here. So if that's the case, you do that. Else, well, let's see here. If it's at 0, meaning it's not being offensive or defensive and not thinking about the next black hole, it could go either way. It could go the direction it's already going. So let's have, is it else if or elif? It's else if. Else if aggro is less than negative tall, so if it's a negative number, then we can have rotation direction equal to math f dot sine of next black hole rotation. And that way, if the aggro level is 0, it'll just continue on its merry way based on whatever direction was already going. Because that's what this helicity takes care of. Okay, cool. So based on that, I should be able to run the code, and it should do exactly what it was doing last time. So let's run the game. We're going to watch the scene view here because that's where we'll be able to see the enemy ship. You can play now. There we go. Okay, so it is heading toward there, and it's going based. Oops, I seem to have. Oh, that's right. I need to fix its toward in a way. It's our min want and our max want. I'm still need to get the physics figured out for that. I'm thinking I'm just going to have to assign some fixed relationship between our min want and our max want, because I still have not figured out a means of physically determining it. Okay, guy, you're kind of messing up there. All right, I thought I did put the the aggro level is 0. Make a note here. Aggro equals 0 is neutral. Did I change anything else about it? I had BVEC. I have next black hole rotation. I've got rotation direction equals negative rotation direction. I've got this helicity business here. Yeah, that should be taking care of it. Oh, unless I need this to actually... Do I need that to actually be closer? Okay, it's turning. Oh, okay, it's approaching from that direction, so it's trying to turn that way. Alright, then let's make this 6 and this 8. How about that? I'm going to have to go back and find out what my values were from the previous episode. There we go. Yeah, except that's too far, because that's not going to bring it anywhere near the array. Well, I spoke too soon. Oh, my ship is heading toward danger there. Ooh, it fell in. Okay, let's see. Let's make this one 5 and this one 4. How about that? It's also possible that I need to begin the ship in a different location. Oh, yeah, I need this thing. Let's move you out this way a little bit. There we go. No. Alright, I didn't change anything about the way it rotates. I didn't change the calculation of RVEC. Alright, let me cut here for a second. I'm going to look up what my values were in the previous episode. I will be right back. Okay, so I checked the video from the last time because I forgot to back up my code. And I had 3 and 6 over here. I also had the enemy ship a little bit closer to the black hole cluster. And so now he's back to normal. So I broke what I fixed. He's able to navigate the black hole field a little bit better. So that's good. And again, those are just experimental values. I still need to figure out a way to, determine those based on the physics of the scenario going on. So, we'll work on that in a future episode. But for right now, what I'd like to do is test the aggro behavior. I think he found an equilibrium point. That's kind of funny. Did not expect that. Well, let's win a game. That was a freebie. Nope, that was not a freebie. All right. Quit playing around. So what I want to test now is the aggro level. So let's see what happens when I make him want to steer toward the nearest black hole, or the next nearest black hole. Oh, that is not what I expected at all. He ended up turning toward the black hole. He should be heading toward that black hole. That's a bit odd. I think it ran into a problem when they were collinear. Let's take a look at that again. This might not work out the way I thought it would. So, for example, right here, this is the nearest black hole, and this is the next nearest black hole. So this position vector is going this way, right? And this position vector is going this way, which means that the angle that we're looking at, the angle that we want him to turn at, is supposed to go from RVec to BVec. So the angle that we want him to turn at, how about I zoom in? There we go. So the angle that we want him to turn goes from here to here. So it's a clockwise rotation. So he should be rotating his nose that way. Let's see what he does. He does not. He's rotating the opposite way. How did I mess that up? Okay, let's try flipping that sign then. It's possible I've misunderstood my cross product setup. Play. There we go. Okay, now he's not really heading toward any of the black holes, it looks like. I think he's sort of caught between those two. Let's try moving him. You know what? Let's try moving him somewhere inside the black hole field. There we go. This way he'll definitely be closest to this one and have a second closest be this one. So he should be turning toward this black hole. Let's see what he does. Nope, he turned away from it. He's doing a nice job avoiding that black hole. All right, let's start that again, this time in pause mode. Okay, so what I want him to do is, I want him to go away from this black hole, but I want him to turn toward this black hole. So let's see what happens there. Let's put this back to negative. All right, let's see what he does. Oh, I just changed the code, which means I need to restart. Recording in the morning has its disadvantages. Okay, good. He's turning toward the next nearest black hole. Is he making any progress? Oh yeah, he is thrusting away from the nearest black hole. Okay, cool. Okay, so now he's trying to go away from this one and toward this one, I think. Oh, you know what is happening probably is this is only Oh no, I've got this happening regardless of whether he's within the R min want range or above the R max want. Do I want it to behave differently regardless of, or do I want it to behave differently based on whether he is moving toward or away? So like, for example, if he's moving away from this one, then I definitely want him moving toward this one. Oh, but if he's moving toward this one, then I don't necessarily want him moving toward this one. Okay, so this little bit of code only matters if he's moving away from the nearest black hole. Okay. So let's do it this way. Control X. Let's actually put that under the heading away from the black hole chunk of code. Because if he's heading away, because if he's heading toward a black hole, he doesn't need to be heading toward the next black hole. And I forgot to move up the next black hole rotation. I'll put that in there. There we go. And I messed up my lovely comment indentation, because I know that's what you came here to see, was me indenting comments. Oops. X. Rotation between nearest black hole and... suppose I should have copied the... should have copied the tabs with it. Okay. So if aggro is greater than tall, blah, blah, blah. Okay, cool. So then this helicity business really only belongs under one of these. Paste and paste. I don't need you printing anymore. All right, let's try that out. I was worried about this thing not always responding to me clicking play, but I've seen enough Unity tutorial videos to realize it happens to other people. I think it's like updating itself in the background or something. Okay, so this is the nearest black hole. He is obviously too close to it, so he's going to want to head away from it, and he's going to turn toward this black hole. Ideally. Let's see what he does. Okay, he turns. Okay, good. He's turning toward that black hole. He should seamlessly be heading toward that black hole. That's kind of a weird behavior. All right, did not expect that one. Oh, and now he's having trouble getting away from it. Oh, probably because he's coasting there? Well, this guy's going to be easy to sink into the black hole, isn't he? Sorry, I know I'm supposed to be testing it. I can't help but play it sometimes. Yeah, right here, we run into a bit of a problem. I think he's... oh, he's coasting there. Because... oh, okay, yeah, I believe he's coasting there because he doesn't seem to be thrusting, and his direction keeps flipping. Which is what you'd expect if he were, you know, trying to point away from and going this way, this way, this way, this way. Okay. Then maybe what I need... maybe I need to close up this distance. Maybe if I'm including this part about... oh, actually, I suppose what I need to do is just take out this part. Because I just copied and pasted that in. All right. Okay, still turning away from that one. Excellent. Okay, yeah, he was definitely in the coasting mode then. He is still coasting. Wait, he shouldn't be rotating if he's coasting, right? I just took that part out. Oh, wait, it does give him a rotation direction if he's coasting. Which I did have that before, that's right. Okay. Oh, all right. He's doing better. Okay, I think this is probably another sign. Okay, this is where it's going to be really cool because he's heading in toward this black hole. And then he's going to head toward this one next. Oh, a little too fast, buddy. A little too fast. So, okay, I think that's just a sign I need to play around with the our min want and our max want. But let's try now a defensive aggro level. See how he behaves differently. I did save that, right? Yes, I did. Whoa, that is not very defensive, buddy. Oh, okay, yeah, because he was heading away from this one. Okay, so now he's moving toward this black hole. And now he's trying to move away from it and the next closest one. Wow, this is actually a very delicate defense. This might be more offensive than the offense. Okay, gotta watch out for my ship. I don't want to end the level. Okay, this is actually working out better than the other one, so I probably need to fine-tune how he approaches. Oops, I'm getting in his way. I probably need to fine-tune for the... Ooh, oh, buddy, that was close. I probably need to fine-tune for the aggro equals yes. I probably need to fine-tune how he's heading toward the next nearest black hole. Actually, he's getting me into a corner here. Oh, and there he goes. Okay, well, he lasted a few cycles there, so that's good. 36 minutes, so let's see. I've been recording for 36 minutes today. Get about 10 minutes on the last one. Okay, so I think that's a pretty good mark of progress. I've at least got the options set up now. I'm still not sure what to make of the behavior when the aggro level is greater than 0. So I probably need to examine that a little bit more. I'll take a look at that off camera and come back with what I've got. In the meantime, if you've got some suggestions over how to make him successfully aggressive, let me know in the comments below. I always look forward to reading viewer comments. And thank you so much for watching. I'll see you next time. Bye-bye.